All right. Well, welcome everybody. Thank you for having me here in Riga. This is my first time in Riga, and I'm actually very excited to be here. As I mentioned, I've not been here before, but also I just love being in movie theaters, don't you? Yeah. The smell of the popcorn, all the posters, all that cool stuff maybe you liked when you were a child. So what we're going to do is we're going to actually move relatively fast for the next 60 minutes. I will try to talk as slow as humanly possible for me, but I tend to talk really fast, and I apologize for that up front. And actually, I'm originally from Alabama, and you would think as a person originally from Alabama and Hawaii, I would talk a lot slower, but I don't. I talk pretty fast. And we have a lot of ground to cover. I want to talk about all these things in the world of cloud native architecture, microservices, Kubernetes. We'll see some Istio. You guys already had a bunch of Istio service mesh sessions, but I'll just give you a little feel for how I look at the service mesh. We'll talk about Knative and Serverless, and we're just generally have a lot of fun over the next 60 minutes. Is that cool? Yep. All right. So let's get started here. First, we had to look up exactly what's going on here in Riga, and turns out you guys are known as the place with incredibly fast internet. Isn't that amazing? And you're probably thinking, not on this Wi-Fi, but no, that's okay. But I want to make sure you guys understand one key thing. And again, I really appreciate your time this evening, because you have to understand that there are at least 7 billion people on this planet, and there are only approximately 10 million professional software developers, of which, maybe 100,000 of those 10 million actually show up for their local user group, show up for their local conference, like this one right now, put on by the wonderful folks who organized this one. And you have to realize that you're actually the elite of the elite. You're the few, the very, very, very few, that are willing to go out and invest in their continuing education and spend time with people like myself giving you a presentation. So I really appreciate that you're here giving me that time today. But I want you guys to understand that, because you're already exceptional just by being here. And that may sound kind of contrite or kind of weird, but I can say that because I've been to a lot of user groups over the years. I've been to a lot of developer conferences, and I know it to be true. So already you're incredibly very special. Now, there was a book that I published recently, so you can go out there and grab it. And it's actually on Istio Service Mesh. You can download it for free. It's an O'Reilly book. So get that. And I have to double check on that bit.ly link. It might be lowercase. My designer was working on my slide deck right before we started, so I don't know if it's lowercase or uppercase at this point. There's also a great presentation I put together for 3 hours going into what's called 9 Steps to Awesome on Kubernetes, and that was recorded by DevOps Belgium. It's out there on YouTube. You want to check that out. And then if you look here, you can see that we are going to be thinking a lot about when it comes to our organization, right? So I want you to think about this one key thing, this key question. Does your organization value custom software application development and APIs and think of that as a strategic advantage? Or does your organization think of you as a cost center, something that has to be streamlined? You want to be working for the former, not the latter. All right, just keep that in mind. Just keep that question as we go through all of this. You want to be thinking about agility. You want to think about DevOps. You want to think about getting better skills for yourself. And then you want to ignore this whole concept of cost cutting and streamlining. That is not what we're about. We are the very few people who can actually be the digital creators of the future. We are the people who can actually put hands on keyboard and make magic happen when it comes to new applications and APIs. And the world wants that. They want that skill set. They want the products that you produce. And I want you to be thinking about that as we go through this content here. All right, so this is your journey to awesomeness. This is my Bruce Lee version of it, the Kung Fu. Kung Fu. All right, so DevOps. DevOps is so critical. We're going to talk more about it in a couple slides still yet. But DevOps is so critical that it'll have the biggest fundamental impact on your professional life. It'll have the hugest impact on your world as a whole, and when it comes to your 9 to 5 and what you do in your average everyday world, everyday job. So keep that in mind. So we'll talk more about that in a second. Also think about self-service and on-demand elastic infrastructure. Here's the key test for this one. If you have to wait even 5 minutes for a resource, you've waited too long at this point in time. It used to be that if you were a software developer and you were working in a large bank or large insurance company or big government, you would say, hey, I need a new virtual machine to basically try something with WebSphere or WebLogic or .NET or Node.js or Python. It had to have Oracle or SQL Server or MongoDB, whatever it had to have with this version of Linux, etc. That would take you about 3 weeks after you filed that ticket. And maybe some of you still spend three weeks waiting for that. But it should be about 5 seconds now, okay? And you'll see why when we talk more about Kubernetes. But that concept of being able to self-service, where you have an API and basically a quota that governs that, that should be something you can do on your own. Now think about your automation. We are no longer feeding CDs and DVDs into trays anymore. No, are we actually going in the SSH, yum install, apt-get install. We shouldn't be doing that anymore either. We should be basically doing all this through a script, some form of playbook, some form of recipe, some form of Chef, Puppet, or Ansible, something of that nature, or maybe just a bash shell script. And also think about your CI/CD deployment pipeline. Okay, in the case of the deployment pipeline, is it something on the back of a napkin? Is it something on a whiteboard? Is it something in a PowerPoint slide? Or is it automated? Maybe like a Jenkins file written in Groovy. Also think about your advanced deployment techniques, and we'll show you some of these. What is a blue-green deployment in your organization? What is a canary deployment in your organization? What does that look like? And I'll show you some examples of those. And then you too can be like Bruce Lee here and think about your next generation of microservices. Okay? I like this concept so much. I've done it multiple times. I call this presentation Teaching Elephants to Dance. You notice there's a key theme here? So it's not just Bruce. There's other heroes in this story. Maybe I have a Wonder Woman version of it as well. So I've been thinking about this problem for quite some time, and I think about it from the perspective of we're all on a journey. We're all growing, we're all evolving, we're all learning, and we're moving forward. So I want you guys to keep that in mind. Now, these are the 12 ways. I'm working on a new presentation called 12 Ways. We're not going to have a chance to spend a lot of time on these things, but I want you to think about things like scale portability, and I'll show you what that means in a second with a demonstration. I also want you to think about Linux containers. Okay, the Linux container fundamentally changed the world and how we actually package our software and ship it now. So we're going to show you some of that as well. Think about Kubernetes, all right, and otherwise cloud native architecture in general. So think about that. And we're going to show you some of these things around Istio and Knative. We're not going to show you Tecton today, but you also should be thinking about some of these key themes. This is a 3-hour presentation right here, this 12 ways one, and we're not going to have a chance to go through all that today. Now, I love this concept right here from Bruce Lee. Adapt what is useful and reject what is useless, and of course, make it your own. So those 12 points I put up there, or even those evolutionary charts, make it your own. Make it speak to you. So let's show you a demonstration. Let's go to get started and just try something incredibly risky right up front. Okay? So we're going to do a demo, and I'm going to need your help. You guys are going to help me right now, because I want to show you something kind of special. Right here is the bit.ly link. I need you to go to that bit.ly link. And it's going to put up a user interface that looks like this one. And then you're going to type in your name, and you're just going to say, how do you pronounce that? Saviki? Sveki? Is that close? All right, so go do that for me real quick. Go to that bit.ly link, Hybrid Cloud 3, type in your name, and you'll notice what happens. It's actually giving you a response from Amazon. And what I'm going to do is show you a couple other things. But let's see who else can get connected to my little user interface on this internet connection here. And so just go ahead and type in a name, just call it test, what it might be there. There you go. Some people are getting connected. Now, let me show you what this thing is doing. Basically, I have a set of Kubernetes clusters built in OpenShift running on Azure, Amazon, Google, and also a separate one, I call it Burr. All right, so 4 different clusters that I can interact with. I can see them all over here. Let's go here. So Amazon Web Services. And of course, I have an OpenShift instance running here. But the good news is, while this is a very unique experience, this is just Kubernetes. Okay? Here's Google. This actual Google is actually running in India. So I actually have my Amazon running in California, my Google running in India. And in the case of my Google, again, it's a very unique experience, but I can treat it just like Kubernetes. I also have Azure running here. Again, a unique experience when it comes to actually putting hands on it, but I have Kubernetes there as well. So the nice thing is your skills are now portable across all the major cloud providers, and here's actually a different version over here. But let's actually play with this a little bit. You guys have been putting in some messages for me? Fantastic. Someone put in boom there. There you go. Pink elephants. I like it. So let's keep watching that, because here's what we're going to do. Let's say that for some reason that it costs too much to run my workload on Amazon any longer. So I'm basically going to come here and type Burr again and hit send request. And notice now they're on the Burr cloud. So I instantly failed over all the transactions that you're typing in right now, including the one I just typed in, to a whole different cloud. And it gets even cooler than that. Let's say I shut off Burr. Okay, let's come over here and come up to this. This is the Burr cloud, and I'm just simply manipulating these pods. Let's drop that down to 0, and then go back over here. And oh, by the way, I have another user interface for this one. Okay, you can kind of see what's happening. So now we're going to go, everybody's going to Google. You guys all failed over to Google. If I shut down Google, you guys get the idea here? You're going to fail over to Azure. So let me shut down Google, and then everybody is on Azure. Now, And so this is kind of cool because I can actually bring these things back up. And here's the point of this. I'm load balancing across all these different clouds, across multiple data centers around the entire globe. My transactions are going where I can process them the fastest or process them the cheapest, or better yet, give the customer the lowest latency by being closer to their physical location, because that's what really matters going forward, is that your customers are better served. And latency is a huge issue when it comes to customer service. If they have to wait 2 seconds to get a response, it's a big deal if they don't, if they have to, if they can wait a little bit shorter than that. It might be the difference between closing the deal and not closing the deal. So let me bring Google back online. Let me bring Amazon back online. I'll bring this one back online. Let's see if we can get them back up here. And it takes a second for all those to start, but we'll get those transaction processors back online here. Okay, and you can see now we're back on Amazon. And if we look at this, you can kind of see what the traffic flow looks like. So most of the traffic is on Amazon. Some of it is going from Google to Azure. And if I actually run a workload generator, let me do that. Let's go and crank up a workload generator just to kind of show you a lot of processing. Okay, so we just want to basically hammer on the system a little bit, send in a bunch of messages. You can kind of see what the difference will be here as it comes online. There we go. It's trying to figure it out. So you can see basically, I'm running a bunch of workload, a bunch of load on Burr. It's mostly processing on Burr because you want the lowest latency. That's the lowest cost typically. But you can also specify what your priority is when it comes to this routing logic. And all this, by the way, is an open source project called Apache Cupid. If you guys are familiar with it, it's another Apache project that Red Hat sponsors, and this is known as the dispatch router. And you can kind of see here, it goes from Google, it goes to Amazon, a little bit on Azure there. If I actually now crank up, or actually, let's do this. If we do this fast enough, it has a nice effect. Okay, and let me see if I do this fast enough. Watch it. There. So basically, I just shut down Burr, so it doesn't have a local transaction processor anymore, so it basically sprays the transactions out to the other 3 clouds. But again, you can determine the priority of this. You can set up the configuration of the route. Right now, I have basically a star topology. You could have a peer-to-peer style topology. It's all a matter of how you want to set that up. But the point of this is, I just deploy my applications to Kubernetes, and it just all works. It doesn't matter what cloud it's in. Is that kind of cool? What do you guys think? Okay. Let's get back into this. And actually, what I'm going to do is so you don't continue playing around with it, I'm going to shut it off. So now you're not going to be able to access that front end anymore. But you guys pumped a lot of messages in there. I like the emoticons, by the way. Fantastic. All right, let's get back into this. All right, that's the first demo. I got a couple more for you. Okay. I mentioned that I was going to talk about DevOps earlier, and DevOps is a key aspect of the journey of where you're going as an individual, as a developer, because there's so many organizations out there that have a DevOps team with no developers on it. Has anyone seen that one before? Well, this is the world we used to live in. We used to think that we had this wall separating the silos between developers and operations, and that's a problem, because we thought we could just throw it over the wall and bonk the other person in the head. But my point with this is we as developers have to find a way to own it again. One of the things I love to tell people is remember back to that first moment you wrote some code. I don't care if you're 5 years old, or if you're 12 years old, or 34 years old, or 54 years old. When you wrote your first block of code, you basically typed it, you saved it, you compiled it, and then you ran it. And when you ran it and you saw that it ran, you basically were so excited, you showed your mom, your dad, your teacher, your husband, your wife, your sister, your brother, your best friend, it didn't matter. You were proud of that moment. And I want you thinking about that again because we need to be back in that moment. Because we're living in a world right now where software development and delivery looks like this. A big amorphous blob that we can't get our arms around. And we have this gang of individuals trying to push it uphill. Have you guys heard the expression, pushing the stone uphill? Rolling the boulder uphill? Does that translate over here? When I was in Australia, they said it's called, oh, wait, in Australia, it's pushing shit uphill. I was like, okay, that really kind of makes the point. But here's what's really funny about this. Can you tell who's pushing in the right direction? Like, who's this person? And if my developers in a room were like, oh, that's ops. They're the people who think they can say no. And actually, I'm here to tell you it's not ops. Not ops. That's probably the security team. Okay? Or your DBA, but it's not ops. How about this person up here? Yeah, your architect team, your architect. You notice they're writing backwards. Okay, for those architect. How about this person down here? That is your ops team, being crushed under the weight of this amorphous blob that you guys have created, just trying to keep it afloat. So I want you thinking about that, because once you've survived one deployment, you'll have to do that crap again and again and again. And it's painful and it sucks every time. And you want to live in a world where it doesn't feel like that, right? You want to live in a world where basically a group of individuals works in a cohesive, nice, modular piece of software. And yes, deployment and to production is never going to be easy, but you can make it easier. You can basically roll it uphill in a nice way, getting everyone moving in the same direction. You can tear down that wall of confusion and basically make dev and ops deliver the software hand in hand together, okay? Now, here's one thing I really like talking about. It's not just dev and ops. And you notice my Harry Potter over there. I'm not saying that my ops person's a wizard. I'm saying he or she loves Harry Potter, okay? I'm not saying my DBA is a zombie. I'm saying my DBA loves The Walking Dead. Because here's the point of this. The entire team are all geeks at this point in time. We all love Big Bang Theory. We all watch Marvel movies at this point, right? We all think about these same characters. We might argue over Star Trek versus Star Wars, security and dev there. But it's actually all part of one big team that has to deliver software together. And the one thing I love talking to people about is you have to think in terms of it's the whole team of heroes that are delivering the software together. It's not any specific group, right, that has to deliver the software. They're all key individuals here. I love the fact that I was able to get Storm from the X-Men in this slide. It took a little while, okay? So hopefully you know these characters. They're incredibly famous. Because the overall goal is basically to process this life cycle right here, where we basically plan for our work. We basically design out whatever we're going to design. We write the code. We build all the automated tests. We do whatever acceptance testing we need. We deploy it, and we iterate through that cycle as fast as possible. So some organizations deploy every 3 months. Some deploy every month. Some deploy every week. And you want to be in a situation where you're deploying ever faster, okay? Ever faster. So if you can basically deploy in once a week versus every 3 months, you're going to have a different trajectory. You can kind of see right here, I have a deployment happening in January, and another one in April. And here's the point. The faster you deploy, the faster you learn. When you put it out in front of real users, that's when you get real feedback. That's when you can pivot. That's when you can zig and zag. So the team that actually deploys in smaller increments has a different trajectory. And by the time the other team realizes this other team is coming, you blow right by them, okay? It's a different way, a different velocity, different trajectory. So think about that for a moment. So those who are unaware they're walking in darkness will never seek the light. Another great quote there. All right, so think about your application for a moment. I come from the Java ecosystem. I've actually only really deployed 2 types of systems to production over the last 25 years or so, Java systems and .NET systems. And actually probably put more .NET applications in production than I did Java applications, but it ended about 13 years ago when I joined JBoss and Red Hat and went all Java at that point in time. But in the case of Java or .NET, the monolithic application was what we knew. We built the whole thing into one, in the case of a Java application, it was an ear file, right? We packed it all in an ear, we deployed it to WebLogic or WebSphere or JBoss. In the case of my .NET application, we bundled it all up. It had a bunch of DLLs in there in some cases, a big old zip file if that's what we needed, but we knew how to deploy that into a IIS, right, on a Windows server. And we could deploy it any different way, but we knew how to get our arms around it, right? We knew what that big old application looked like. Well, what has happened is we started basically breaking up that application and thinking about its components, its modules, its microservices. That's the world we're living in now. And the reason we broke it up is because we want to move these individual parts faster than the overall monolith could roll. We want to deploy ever faster. But what gets weird is we start taking these microservices and pushing them around a network. And when we have that network connection between them, that's when it gets hard. That's when it gets really crazy. That's when things break. Also, you might have your own data, right? In a microservices architecture, everyone should have their own database. No longer a monolithic database in that architecture. And of course, multiple points of entry, where you have multiple API surface layers now. It used to be you had one portal, and that was how you access the application, one big user interface. Now you have multiple points of interaction with the back end, and that means you have to think through your API governance and API security, or your API management. You also have multiple pipelines with multiple teams pushing these things to production at their interval. So it does get really complex really fast. These are the microservices principles. Just be aware of them. We're not going to have time to spend a lot of time on them. But all these independent teams have their own independent pipeline, producing their own independent product at their independent interval. It's the ultimate goal. If you can ship every Tuesday, if your team can ship every Tuesday at 9 a.m., do so. If that other team can ship every other Wednesday at 10 a.m., they should. If this other team over here can deliver every day, Monday through Thursday at 10 a.m., they will. It's a different way of thinking. And so that's why we talk about things like Kubernetes. So you have the old school world and the new school world, okay? So in the new school world, we have microservices, which basically represents distributed computing. We have an application running inside an operating system, maybe on a virtual machine with a JVM there, with a service A talking to service B, talking to service C. And so the problem with that is the fallacies of network computing, distributed computing. The network is certainly not reliable, latency is never zero, bandwidth is never infinite, because a failure in one of these services might cause a cascading failure throughout the entire network. And that's what you don't want. You don't want your service mesh to blow up. So we talk about these key capabilities for your microservices architecture. How do you address all these points with service discovery, invocation models, elasticity, scale out, scale back, resiliency, make a resilient call, and if it fails, at least trap that call, maybe like a circuit breaker or some sort of fallback position. A pipeline, what is your automation for a pipeline? Your authentication, authorization, logging, monitoring, tracing. You got to think through all of these things. And more importantly, you should think through all of these things for the programming language that you're interested in. Okay? So this is where Istio comes into play, because it sits on top of a Kubernetes architecture and gives you a lot of these key capabilities. So before Istio, if you had a JVM-based application, you would put these things like discovery and load balancing, resiliency, metric capture, tracing, all that within the body of the application. Actual jar files in your POM XML in the overall fat jar that you created, and then you could connect these dots, and it worked out really well. Now, after Istio has been born, you can use the sidecar, known as Envoy, to do the same thing. Okay? Now, this is the architecture for Istio. You guys have seen some Istio sessions today. What I want to do, though, is show you some different parts of this. Okay? I'll show you some different aspects of it and give you a little demonstration of it. But you can kind of see right there, basically, the traffic of the data plane flows through the sidecar. The sidecar intercepts all traffic going in and out of that pod. So a lot of people didn't realize this, that when it came to a Kubernetes pod, that a pod actually could have multiple containers in it. So it doesn't have to have one-for-one Linux containers in one pod. You can have multiple. And in this case, you can see the control plane here, the pilot, the mixer, the citadel, and the galley. They're interacting with those different envoys that are running out there. So the good news is if you wanted to, you could actually just deploy Envoy en masse on your own. Right? It's an open source project written in C++, put in production by the Lyft team, the Lyft, not Uber team, right? And they've been using it for quite some time. Other teams out there in the Internet Valley, Silicon Valley are also using it. But you could do the same. The downside is you now have to get into every one of those pods and tweak it if the rules change. With Istio, you have one place to put those rules, and Istio makes sure that it gets processed out there. So we'll show you some examples of that. This is Kiali, which is an open source project that we contributed into the Istio ecosystem. So Alyssa, who's here someplace, she actually works on that project. So let's actually do a little demo for you. Another great quote from Showing Off is a Fool's Idea of Glory. So let's give it a try. Okay? I'm going to come in here now, and if I get the right window, let's see here. So this is basically, I'm connected to my Kubernetes cluster. kubectl get namespaces. I have a lot going on in it. All right, good. We're still connected. Looks like the internet's working. Let's see, project tutorial. Let me make sure I'm in the right namespace. Okay, and kubectl get pods. I have a bunch of things running in this cluster, though. So you can see I've got a lot going on here. Okay, but we don't have to worry about all that. I can also say get nodes. So I have a real cluster here. You can see these are all the worker nodes I'm working on that have been out there for a little while. But what I want to show you is this. I have these 3 microservices. Come on, type Burr. Here that are customer preference and recommendation. So this is a simple little application where a customer calls preference, preference calls recommendation. That series of transactions has to occur to get a valid response back to our user. Let me try to pull it and see if we get some data there. Okay, so you can actually, if you want to, you could hit the same URL. Okay, you could go to that same URL. As a matter of fact, I think I have another bit.ly link for that one. I think it's this one. Let me double check it. I think where I was last. Okay, there we go. So if you wanted, you could also go to this bit.ly link for anyone who wants to try that real fast. Jump on that one right there, and you can actually see what we're going to be doing here. So this is my little application, very simple. Okay, and the first thing I want to do is deploy a second version of my application. I already have it built. Let's just go ahead and deploy it. So I just have a bunch of scripts here to make it easy. So I'm now deploying a version 2 of my recommendation engine. So this is a concept where we're practicing CI/CD. We're moving super fast. I'm going to deploy a new version of my application. You can see it's going out to production right now. Notice when it goes 2 by 2, that means in fact it is ready. And then you'll notice it gets automatically added to the sidecar, or sorry, the load balancer. And so here we go. Come on, 2 by 2. There we go. And there is the second version 2 right there. Okay. So if I wanted to, I could come in here and actually change the code. Maybe we should have done that just to make it a little bit more interesting. All right. So let's do that real quick. I'll bring up my editor here. I think I'm editing the right files. And let's go here. I'm going to come in here and change this one. If I want to, I can come in here and say that. Okay. And this one just says version 2. Let's make this Riga recommendation. Okay, you can just make a change. And so I can hit save. I can hit Maven package. That's Java code. Yeah, I know for some people you're like, oh, don't show us Java code. But it's okay. It'll be all right. You'll see in a little bit. Yeah, skip tests. I think I have a test error there. Oh, I'm actually not even in the right directory. It helps if you're in the right directory. Yeah, Java, of course, Maven package. All right. So you can just build it like you normally would and then deploy it. Do note, though, that when you're deploying in this kind of world, what is the issue here? Test failures, exactly, because I changed the thing without changing my test. Okay. Let's see here if this will work for me this time. Nope, helps if you skip test correctly. But you can see this is just kind of a live demonstration of things, right? So if I look at my target, you can kind of see there's this runner jar here. And so we're actually going to dig into this concept called Quarkus a little bit more tomorrow. But let me try this. I'm going to go now build it. Let's go ahead and build it. So I have another script here that's going to build the native executable. I'm going to let that run. Okay, and so let that be for now. And while that's going along, let's have a little fun with this thing. So you guys got connected to my little application, right? You can kind of see what it's doing. So it's going 1, 2, 1, 2, 1, 2. Okay, it just goes back and forth. And if I bring up my Firefox over here, you can see it should just go 1, 2. Okay, we're back and forth between those two things. And now with something like Istio, I can do some really interesting things. I can do things like, well, let's move all our users over to version 2. Okay, so basically you'll notice that everybody is going to get switched over to version 2 and no one sees version 1 anymore. So version 2 and version 1 are still deployed. So this is basically a blue-green deployment. I have 1 and 2 in production. I'm practicing CI/CD. I'm deploying super fast. So they're both out there right now, but I just switched all my users over to version 2. And here's the part that's kind of cool about that. If the marketing department complains like, oh my God, you shouldn't have done that. We didn't really want that version out there in production. You could say, well, let's switch everybody back to version 1. And you can say, okay, everybody's back on version 1. So something as simple as that, just switching between those two pods, is a pretty neat feature that you have now with Istio on top of Kubernetes. With Kubernetes, it's going to do round-robin load balancing. If you have 2 pods, it's going to do 50-50 load balancing. If you have 4 pods, it's 25, 25, 25, 25. With Istio, you're now going to basically be able to split that traffic and go in different directions. So now I'm back on version 1, and let's say I want to do something instead of a full all-or-nothing kind of deployment. I want to do a canary deployment, right? So let's actually do a 90-10 split. So with the 90-10 split, you'll notice here my little polar, every now and then you'll see a version 2. And a lot will depend on who else is also refreshing their browser and if they get a version 2 before I do. Okay, but you can kind of see that you'll just, every 10% of the transactions will net you a version 2. And so that's a simple kind of canary. I just want basically a subset of my users to get the new version before anyone else does, and that way I can basically monitor Twitter or the help desk and see if people really start complaining. That might be your strategy. Okay, but that's actually still a fairly coarse-grained thing. So let me actually clean that out. And what I'm doing is simply changing the virtual services and destination rules. I'm just going to wipe that out. You'll see now it goes back to a clean 1 and 2. And what I want to do now is basically say, okay, let's make it so that everybody goes to version 1, but only our Safari users go to version 2. So here's my Firefox. It's all version 1. And let me go to my Safari over here. Okay. And you can see Safari is all version 2. So what this means is you can use the HTTP headers to basically determine what the routes are. So I'm just using user agent in this case, but you could say, oh, mobile users go to version 2. All users that are logged in and have checked the beta flag are going to version 2. Only employees go to version 2. You can pick whatever strategy you want, and that's the type of canary rollout. Basically, I'm just giving this change, the new version of the application, to a small subset of users, and I'm not impacting the whole of the user base until I decide that they should see it. And again, you can easily take those rules back out. So this is just a kubectl get virtual services. All right, so this is just a get virtual service. There's otherwise things known as get CRDs in this version of Kubernetes. So basically, this is the way to extend Kubernetes architecture with all these cool capabilities like KALI, like virtual services, like destination rules, like Knative, which you'll see in a little bit in a moment. But let's do this now. I basically built the native image. Okay, so let's do a Docker build. Dun, 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 dun. I want to push out that change I was making. And then I'm going to do the Docker push. Okay, we're making sure it gets pushed out there. That looks like it's going. Fantastic. And if I come over to my Docker Hub, I'll see if it made it. So go to repositories and recommendation. All right, looks like it just made it. And if I did everything correctly, we can have a little fun with this. Deployment. I'm just hacking on this thing now. This is not actually the way you're supposed to do it, but you know, if you have the power, why not give it a shot? All right, so what I'm going to do is I'm going to switch this to Docker.io, Burr Sutter. I'm actually changing the image name or the image identifier associated with this thing. And actually, let's knock this thing down to, you know, actually get that. I think we can get down to 20 on the heap size, and watch what happens over here. All right, so I just basically went into Kubernetes, and Kubernetes has this declarative concept, right? Basically has a concept of a deployment. The deployment says, what image would you like to run at scale? And you determine, you know, through that deployment artifact, you just create that YAML document. What image are you going to run? And I basically just changed the image that it's pointing to. So I pointed it to a whole different image. And so what that does is it says, okay, I need to terminate the old one and bring up the new one. And you notice what happened when it's bringing up the new one. It did not actually see any errors. We did not see any change. The user's still on V1, okay? The user's still on V1, and that's kind of cool. So if I clean out the rules, you'll now see the Burr recommendation. So I actually had a different version of that image out there, okay? So I apparently had messed something up along the way, but you can basically pick and choose which image is what's deployed, and based on your rules, you can kind of route around problems with it. And of course, there's like the KALI console for doing things like, you know, seeing this. You can kind of see that I had some errors earlier there, and you can kind of have a lot of fun with it. So that's just a quick and dirty on Istio, and we don't want to spend a lot of time there, but I just want to give you a feel for that level of dynamic capability you might have in this world we're living in now with a Kubernetes-based architecture, the ability to deploy incredibly fast, change routing logic on the fly, and basically move users to the right location. But there's more I want to show you. As I said, this is like a 3-hour presentation. We're putting it in 1 hour. Okay? Be happy but never satisfied. I love that quote too. Because in this new world of microservices and distributed computing architecture, we no longer are satisfied with just old microservices. We want serverless architecture also. We want function as a service if we can have it. We want a way to basically say, you know what, that microservice is so micro that it only lives for periods at a time. Maybe only for 90 seconds, maybe only for an hour. And it's basically only going to live as long as there's load that drives the need to keep that service up. By default, we scale the service back down to nothing, if at all possible. So it's a different way of thinking about application level architecture. You start writing your app knowing that it won't be stateful, if you will. It won't be sitting in resident, always on. Because with a microservice, it's always on. It's always listening. It's always holding a port open. It's always got a thread pool. It's always got a bunch of memory it's using, even if no users are using it. That's what we did with our old monolithic applications in any language, Node.js, .NET, Python, Java, doesn't matter. In this new world, it pops up, does its job, goes away. So different way of thinking. So the first thing you should think about in this new architecture is there a suitable service I can consume? Because in a serverless world, it's all about the backend as a service, it's all about the solver as a service. So the services are things like API gateway. What is the API gateway service I'm going to have? I can easily go get an Nginx, write some Lua code, hack it to death, and build my own API gateway. But I probably just want to get one from somebody that already gives me that for free, if you will. I don't need to build one on my own. As a matter of fact, I can get SSO out there. There's a great open source project sponsored by Red Hat called Keycloak. And so I can get a great SSO, does SAML, it does JSON Web Token out of the box. It manages all the users, gives a forgot password screen, the whole 9 yards. I don't have to think about user management. I don't have to think about SSO. Basically get that as a service. I can think about storage as a service. I don't want to build a globally distributed storage mechanism. I can just go use Amazon S3 and not worry about it anymore. I could basically go pick a database from a different vendor, or I could write my own code for a database. Some people do. I know there's people in this room right now who are like, I can write my own database engine. I did that in school. And you probably think you should. But in many cases, what I'm going to tell you is just go pick a database. How about notifications as a service? Push notifications or emails, text messages, or messaging as a service where we have some form of message broker in the sky. Basically take advantage of it there. And so once you build all these services, once you buy all these services, you then build the custom business logic, the differentiating business logic that is uniquely your own, and that is stateful and long-running. These microservices are always on by default. But then you have other pieces of your application infrastructure that are not always on, and we call those functions for now. And what you'll see in a second, though, is with Knative, it's actually still a microservice, just not always on, okay? And you can basically connect all the dots through these functions. And of course, all of this is consumed by your business partners through your API layer, through your desktop application, through your mobile application. And all that is, one big application from the experience of the end user. All right. I also want to mention this concept of supersonic subatomic Java. This is the presentation I'll be doing tomorrow. And we're going to talk also about Knative. So I want to show you some of these things. All right. Let's see if we can show you this. One thing that I want to show you, let's actually stop this. That's the Istio stuff. Let's go back here. Oh, come on, window. There we go. One thing is, you saw me compiled to native code my Java-based application, right? So if here's an example of a larger Java application. We won't spend a lot of time here, and I'll show this more tomorrow. But here's a Java application with object relational mapping, and basically has a REST endpoint. Pretty standard stuff if you're familiar with JAX-RS and JPA. And then I can literally compile that to a native executable, okay? So I think I did that earlier. And so right here, let me see if I can bring it up real fast. Let's go do this. Target, to do. All right, so there's a whole application started in 0.64 seconds. That includes the setting up of the database schema, configures the schema, making the connection pool, setting up that API layer, and that's a Java-based application. So think about that for 1 second. So that's what we're going to talk about when we do Quarkus presentation tomorrow. But for now, we're going to have some fun with some other things, okay? I want to show you this thing called Knative. So if I go over here to say kubectl, get namespaces, you're going to basically see that there's some namespaces out here called Knative. And also there's some CRDs. Not that. Get to Knative, and we want to get the Knative CRDs too. Oh, let's not put get there again. Yeah. We want to say grep. Come on, Burr. Moving too fast. All right, so there's the CRDs, the custom resource definitions. Again, what a CRD does is it extends the Kubernetes architecture to give you these additional capabilities, these additional superpowers. But what I want to do now, let's see if I can make a mess of this. Maybe I will. I actually did something on the flight over. I said, you know what? At RigaDevDays, you guys are also .NET people. I thought, well, let's have a little fun with .NET. I haven't tried it in a few years, but I built, it was pretty easy to get a little hello world here. Let's see if I can get this right here. Is that spelled correctly? Okay. So we're going to basically we have a little C# app. Okay. And the cool thing about that is I can say .NET run. I do have some .NET people here, right? And they're quiet. They're very quiet. They're keeping their head down. Let's go here. And so, okay, there it is. So there's my little application. I did my little test on it. And then I want to come in here now and hit Control-C. So we have another script here that does my Docker build, because this is the process you go through. You build your application in whatever editor you want. You do your build of that application, like using a Maven build, or in this case, I'm just using .NET. Then you do your Docker build, all right? So if you look at the Docker build, it's very straightforward. It's just a Docker build command. You got to give it the Docker file name, and then of course you got to give it a local image name. So I'm going to say Docker images, grep C# is what I call that image, and Docker images. There we go, and there it is. That's the one, and then I got to push it. Okay, so that's the next step. You go through Docker push, and I'm going to push it out to the public internet. In this case, it's going out to Docker.io, and it's pushing that image out there. So there it goes. Almost. The internet, performance is pretty good here. Like we said earlier, look at that, done. Okay, so what I'm going to do now is have a little fun with this. Let's go see project, switch namespaces. All right, so I'm in a new namespace. You notice there's no pods running. The pod is the computer in which this application will run. But what I want to do is now deploy this application using Knative. All right, so Knative has a different structure for its deployment artifact. It has this concept of a service, and you notice the API version here. You also can set the auto-scale target, 10 concurrency in this case, and here's the image name. So that's the image I just created, and I also set image pull policy always, so that it actually knows to download it again and again every time I change it. Otherwise, I should just change the number, and you notice I didn't do that, I was lazy. But right now, that is the artifact you create for basically saying deploy this thing inside of Kubernetes, and then again, this is the Knative version of that. And I say kubectl create -f kube files, and then the kn service, and Docker. Okay, if I did everything correctly there, you will see a new pod springing to life. And so what's happening is you're going to get a deployment artifact. You're going to get a pod. You see the pod coming there. You also get a replica set. Okay, you can see I have other things running here too. So there's actually a Spring Boot app. There's a C# app. There's the Go application, a Node application, a Python application, and a Quarkus application. And now I have a .NET application. And then I can basically, once it goes 3 by 3, that's when in fact it is ready. And let's see here. kubectl get k service. Let's see, is it ready? Yeah, it's ready now. And I can basically use this URL and say curl, and you can do the same from your chair. All right, so I'm now interacting with that application. And here's what's kind of cool about this. If in fact I no longer use this application, no button hits it, you'll see it scale down automatically. And that's what's happened with these other applications that are technically out here running, and you don't see any pods for them. So there's no memory being used by these guys. So if I come here to Node.js, let's go and bring up my Node.js application by basically throwing a bunch of load at it. Okay, I'm going to pound on my Node.js application. That 40 concurrent users all sending in their request right now. You notice it dynamically auto scales to 4 different pods to basically say, oh my God, there's a whole bunch of load coming in. Let me get these pods up and running for you automatically. As soon as one pod becomes available, I'll flush the traffic down it. You can see there's all the traffic. And in 18 seconds is your cold start latency from nothing, absolutely nothing running, to something running and responding to all those requests. If I come here now and just simply poll it, okay, I'm just polling it. It just basically will keep it alive. And you'll notice if you pay attention that because I'm just polling about 3 transactions per second now, one user, 3 transactions per second, it'll start to terminate the Node.js applications it doesn't need. So Knative is being super clever. By default with Kubernetes, you say I have to have it running, and it keeps it running for you. Its job is to keep it running. Knative adds some additional logic on top of that that says, based on your load, in this case HTTP load, scale out more and start to rip it down when you don't need it. So that concept's very, very powerful. And Knative does a lot more than just this one trick, but this is kind of the most notable thing that it does. See, there's with 3 terminating. And notice my C# one's, apparently you guys didn't actually get on that URL because now the C# one's also terminating. And then I can also come over here now and do the same thing with my Quarkus app. And we'll get that running. All right, so here comes the Quarkus app coming online. Same thing as before. I hit it with a lot of load, therefore it springs back to life. And what I want to show you is this. Okay, so here's my Node.js application, or actually that's my C# application. C# running about 32, 33 megs of RAM. My my .NET application, 33 megs of RAM. My Node.js application running in 29 megs of RAM. Okay, and let's make sure we get this right. And here's my Quarkus application running in 15 megs of RAM. The Java application is half the size of the .NET application and Node.js application. And your mileage will vary, right? You will see different properties here based on what you're doing. You'll notice also that my C# application came up, or sorry, my Quarkus application came up a little bit faster. This is the problem with doing too many things simultaneously. but we'll pull that. So that'll keep Quarkus alive, Node.js alive. And I'm interested in seeing my .NET application come back. So I also built a little tool to hit it hard again. So we'll get my .NET application back to life. So here it comes. But this is the basic concept here. Okay, so you're probably thinking, okay, this is just all kind of weird. But if you were hitting these same URLs from your phone, you could, because this is all out there in public internet, you would also be keeping those same pods alive. Any traffic that shows up within 60 to 90 second interval keeps the pod alive. That's the purpose of Knative. If there's no traffic at all, for instance, your customers have gone to sleep, or better yet, you always scale for peak. That's what we do in our infrastructure today. We basically scale for peak, and then when things happen, let's see here, my C#? Yeah, it's up and running. I kind of overloaded a little bit there, but there we go. You guys always scale for peak. That means if you need 4 servers to run your peak load, you have 4 servers. If you need 25 servers, you have 25 servers. But what happens if your users aren't at peak? And they're not. Your users all show up at Monday morning at 9 o'clock in the morning because they're traders in Wall Street, right? Or they are, and it's 9 o'clock in London in your case. Or better yet, you have a bunch of retail customers all come in on Black Friday or whatever your version of that is. They all show up on Saturday morning. Your nurses all clock in at 5 p.m. every Thursday night because that's when they're coming to work. So that's when you scale, that's when your peak is. Why do you have to have all this infrastructure out there if it's not needed at that point in time? And again, kind of the coolest part about this is you can kind of see right here, like the Quarkus application, the Java application is a lot smaller than the others. And I just got this .NET application really before when I was flying over here. Okay, what do you guys think about that? You're a quiet bunch. Am I talking way too fast? Okay. Well, let's try to get things a little bit more wrapped up here. So Quarkus, we're going to talk more about in our presentation tomorrow, but the idea is it's Java compiled down to native code. It also runs in JVM mode, and you can kind of see that it's incredibly lightweight, super fast, very small. And then Knative, I have this additional ability over and above my Istio, over and above my Kubernetes, right? So I still have my base Kubernetes here. I still have my get pods. I still have my base Istio here, Istio system. Okay, so there's my Istio, and I have my Knative on top. All right, so in a single cluster, I have these additional layers on top that give me these additional capabilities, like I showed you earlier, the ability to change routes on the fly, the ability to basically scale up, scale down dynamically based on needs. So let's kind of wrap this thing up here. Okay, so there are 3 primary components of Knative. It's build is one of them, but build is kind of going away, so I drew a line through that. It's going to be changing projects very soon, so you're going to see build kind of disappear and move to a new project called Tekton. Serving is what I just demonstrated to you, the ability to dynamically scale out, burst out, and of course downscale based on the fact there's no load. So the Knative is constantly monitoring the environment. It says, okay, if there's no load, take those pods away. So you just have to think of that pod as a whole server, because your JVM, your C#, your Node.js V8 runtime thinks it's a whole server. If you notice, I basically display the computer name for a reason. In Java, Node.js, Python, Go, etc., it thinks it's running on its own computer. Okay, and that's what I did with the C# there as well. And of course, there's .NET eventing. So with the, .NET eventing, the Knative eventing. So the eventing basically says go beyond HTTP. I want Kafka to be the load that causes the burst, as an example. I want a polar against Salesforce and a bunch of Salesforce records show up to be the burst. I want Amazon SQS, right? Messages coming through SQS to be the burst. So there's different ways to actually cause that dynamic scale out than just HTTP. All right, and so Kafka is probably the most interesting one in that batch right now. So this is what Knative is. It's a bunch of primitives based on top of middleware components and primitives for container-based applications sitting on top of Kubernetes. So just keep that in mind. It gives you this really cool scale to 0, scale from 0, configuration revision, so you can do blue-green deployments. You have in-cluster image building. That's the build that's moving to its own project. And that means instead of doing a Docker build like you saw me do real fast, it does the build in cluster. So just keep that in mind. Traffic splitting and, of course, the eventing system. One other thing I'd encourage you guys to check out is this book here. If you saw earlier when I showed you the microservices mesh, the architecture, there's all these different databases. So a key question we often get is how do you deal with all those databases, as an example? You know, more importantly, I have one centralized schema, one big old application database for my whole application, and now I need to split it up in all these little different databases. So there's a ton of tips and techniques in here from Edson Yanaga. I think he's been here before. I may have spoke on this topic last year, I think. So definitely check that book out. There's also a bunch of other content. So the Istio thing that you saw me running earlier, you can see bit.ly Istio tutorial. The Knative thing you saw me just running, Knative tutorial. So you can actually go try these things yourself. These are all this information that's out there on GitHub. I want to make sure that you're empowered to go try all this stuff on your laptop or on your cluster, stand it up and get going. So just keep that in mind. You have all that. And so a couple more things here. Don't fear failure, not failure, but low aim is the crime. In great attempts, it is glorious even to fail. This is a key point if you took nothing away from this whole presentation. If you're always learning, experimenting, failing, but learning, you're winning. Okay? And that what you just saw with Istio and Knative and all this stuff that we did with Kubernetes is you can actually fail in production. That's what the Silicon Valley folks do now. They deploy so fast, they know failure is going to happen. They do not try to prevent failure in production. They just try to move as fast as possible, and when a failure occurs, they just want to fix it as fast as possible. And if you have a 3-month deployment interval, it could take you 3 months to fix a problem. If you have a 3-minute deployment interval, it only takes you 3 minutes to fix a problem. And if you have a critical vulnerability, an exploit, that you have to patch in your base images for your Linux runtime, your Linux operating system, how fast can you patch those and ensure that the application stays up? So that's probably the most important thing at this point in time to be thinking about. We want to practice CI/CD, and we want to be able to deploy in minutes to production, just in case a massive exploit happens and actually takes down our entire infrastructure, or better yet, causes us to lose all our customer data to somebody on the internet. Or maybe even run a Bitcoin miner for somebody. That seems to be happening a lot. So I want to leave you with that. It is just the beginning. There's a lot of cool stuff that's coming your way. The bit.ly link here at the bottom where it says bit.ly Riga Burr 2019, that'll get you access to this slide deck. Therefore, you'll get access to all the other links in that slide deck. I saw some folks taking pictures, but you can go grab all those links and then have all this content for yourself. And then I look forward to seeing you guys for the Quarkus session tomorrow. At this point, I think we're out of time officially, aren't we? Okay, and we're ready for a party? Do you guys have any closing comments?
No.
No? All right. Well, I thank you all so much for spending an hour with me. Hopefully, did you guys get something out of this session? And for my .NET people here, did you feel some love? You can say yes, all right, because those Java people, they're kind of snooty, okay? Yeah. But again, thank you so much, and we'll see you at the reception. Thank you.
Yeah, so we're heading out to Speakery. That's it.